In the relentless pursuit of elite performance, the mission has evolved. Modern warriors are not just trained, they're engineered through physiology, precision, and intent. Every heartbeat, every muscle fiber, every neural signal has a purpose. Behind the front lines, scientists and performance specialists analyze the human body like a living weapon system, studying how stress, fatigue, and adaptation interconnect. Because in today's battles, whether on the ground, in the air, or in extreme environments, the body is the platform, and physiology is the science that keeps it operational. True human performance begins with understanding energy systems. The ATP phosphocreatine system fuels short bursts of explosive movement, sprints, lifts, breaching maneuvers. The glycolytic system carries the fight into the next phase, powering sustained efforts up to several minutes under anaerobic conditions. Beyond that, the aerobic system takes command, providing endurance and recovery through oxygen efficiency and mitochondrial density. Training across these systems ensures that when fatigue sets in, the body doesn't fail. It shifts gears. This balance of power and endurance defines the modern operator, capable of immediate aggression and prolonged resilience. Performance isn't just about strength, it's about how the body maintains efficiency under fatigue. Every contraction triggers microscopic muscle damage, metabolic byproduct accumulation, and heat generation. The cardiovascular system responds by increasing heart rate, stroke volume, and peripheral blood flow, while the respiratory system regulates gas exchange to sustain aerobic metabolism. The lactate threshold, once seen as a limit, is now trained as a weapon, allowing soldiers to buffer acidity and maintain power output longer. The difference between breaking down and breaking through lies in how well the body manages stress at the cellular level. But physiology extends far beyond the body. The brain governs performance through the central governor model, regulating effort based on perceived fatigue. The stronger the connection between mind and muscle, the greater the body's access to untapped reserves. Biofeedback and heart rate variability, HRV, monitoring allow operators to see how their nervous system reacts under pressure. A low HRV might signal overtraining or poor recovery, while a balanced rhythm indicates resilience. By understanding these metrics, soldiers can modify workload, manage stress, and maintain peak performance with surgical precision. Cognitive performance is equally critical. In high-stakes operations, the difference between mission success and failure can hinge on a single delayed reaction. Neuroscientists now study prefrontal cortex activation and neurotransmitter regulation to understand decision-making under stress. Through simulation training and tactical drills, operators learn to maintain executive function while their physiology screams for rest. It's the science of composure, where adrenaline sharpens focus instead of clouding it. Environmental physiology adds another layer of complexity. Heat, cold, altitude, and gravity each impose unique physiological demands. In desert warfare, the hypothalamus regulates body temperature through vasodilation and sweating, but excessive heat can cause dehydration, electrolyte loss, and cardiovascular strain. Heat acclimatization training expands plasma volume, improves thermoregulation, and delays fatigue. In contrast, cold exposure triggers vasoconstriction and shivering thermogenesis, increasing norepinephrine release and mental alertness. At altitude, erythropoietin, EPO, production rises, enhancing red blood cell count and oxygen delivery. Every stressor, when trained deliberately, becomes an adaptive weapon, reshaping the body to survive where others collapse. Aerospace physiology takes these principles further. At high altitude, or in high G flight, the baroreceptor reflex struggles to stabilize blood pressure. Pilots train anti-G maneuvers and controlled breathing techniques to maintain consciousness during acceleration, combating G-lock, gravity-induced loss of consciousness. Hypoxia training chambers condition aircrew to recognize early oxygen deprivation symptoms, enabling immediate correction before cognitive decline. Even microgravity environments affect muscle mass, bone density, and fluid distribution, proving that the human body is constantly adapting to the physics around it. Understanding these mechanisms isn't theory, it's survival. Recovery, often overlooked, is the foundation of readiness. Physiological restoration allows performance to be repeated at elite levels. Sleep drives hormonal regulation, memory consolidation, and tissue repair through growth hormone secretion. Cold water immersion reduces inflammation, compression therapy aids venous return, and parasympathetic breathing restores balance to the autonomic nervous system. Nutrition completes the cycle. Glycogen replenishment, amino acid repair, and hydration ensure that the next mission starts at full capacity. Without recovery, training is just damage. With recovery, training becomes adaptation. Each session, each controlled exposure, each micro-adjustment in data and feedback builds a system of resilience. Soldiers learn to listen to their physiology, not to coddle it, but to command it. Strength training increases neural drive and force production. Endurance work enhances cardiac output and capillary density. Tactical simulations refine reaction time, proprioception, and decision-making. When these layers combine, the result is a human system built for precision and endurance, not chaos and exhaustion. The future of military physiology lies in integration. Wearable biosensors now monitor hydration, temperature, and cognitive load in real time. Neurofeedback headsets train focus and emotional regulation. Exoskeleton research combines biomechanics with robotics to enhance load carriage efficiency. Artificial intelligence analyzes thousands of data points per session, customizing recovery and optimizing readiness. Yet even with advancing technology, the foundation remains unchanged: discipline, adaptation, and human resilience. The modern warrior is part soldier, part scientist. Guided by data, fueled by adaptation, sustained by discipline. Every rep, every breath, every recovery cycle builds a system capable of thriving in chaos. Aerospace and military physiology are merging, redefining what it means to be mission-ready. This is not just human performance, it's human optimization, the next evolution of readiness. Train the body. Master the mind. Endure the mission.